Okay, so the setup. This is a bottle cork made of plastic. This is a regular bottle cork, nothing special about it. This is a board. It's made of wood and it has a relatively rough surface. Some important topics to understand before we begin this experiment is as follows. Static friction is the force that prevents an object from starting to move. Kinetic friction is the force that is parallel to the surface that resists the continued sliding of an object that is already in motion. In this experiment, you will see both of these forces of friction coming into play. An important concept to understand before I start this experiment is that static friction has a limit. This means that if I apply enough force to an object, it will eventually begin to move. In this experiment, the object is obviously the cork. The source of friction will be on the board. The applied force will vary according to how large the angle of the board is. Thus, if I hold the board at a very large angle, a very high angle, it will have more applied force. Okay, so here we go. The cork, the board. As you can see, the cork did not begin to move with the board until the board was tilted somewhere around a 60-degree angle. This is because there was a reasonably large force of static friction, preventing the cork from moving. Being that this board was so short, however, meaning that the board had a small runway for the cork to run on, one was not able to see kinetic friction at work. Nevertheless, kinetic friction was still present. If I was to level the board at a 0-degree angle, which it is right now, and to give the cork a applied force, kinetic friction would slow the movement of the cork and eventually bring it to a stop, which is what we see. At the point where the cork began to slide, the weight of the cork parallel to the board was equal to the maximum force of static friction. Other important concepts that could be drawn from this experiment is as follows. Notice that the cork began to accelerate and not move at a constant velocity down the board. This is because the coefficient of kinetic friction was less than that of static friction. Once the static friction limit had been reached, the cork, with some steam left over from the applied force, overpowered the kinetic friction acting against the cork's movement. Thus, the cork began to accelerate.